Alright, so in the previous section, section 8.2, I went over linear functions. Today I'm gonna go over 8.3, which is nonlinear functions. Section 8.3, graphs of nonlinear functions. Well, as we all know, to graph anything, we need to make a t-chart. So we're gonna first talk about few basic graphs. And those basic graphs should be known by heart. The first one is f of x equals x squared. It's a U-shaped graph. Let's see why it's a U-shaped. We're gonna plug in some points, couple of negatives, 0 and couple of positives. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and then 2 squared is 4. If we graph that, -2, 4, -1, 1, 0, 0, 1, 1, and then 2, 4. And you get a U-shaped graph. And so whenever we see a squared function, it's going to look like that, U-shaped. And then the second basic graph that we're going to talk about is the V-shaped. A V-shaped graph, y equals, or f of x equals absolute value of x. Again, if we plug in the same y values, the same x values in there, we get absolute value of -2, absolute value of -1, and then we plot these points on the rectangular system of coordinates, -2, 2, -1, 1, 0, 0, 1, 1, and then 2, 2. And you can see it's a V-shaped. It doesn't curve. It has a sharp edge at the origin, a V-shaped. And then the third graph that we should know by heart is the cubic function, f of x equals x cubed. This doesn't really have a specific shape. I call it the increasing shape. So if we plug in -2, we get -2 cubed, which is -8, -1 cubed, and then 0 cubed, 1 cubed, and then 2 cubed is 8. And if we graph that, if we plot these points, -2, -8, -1, -1, 0, 0, 1, 1, and then 2, 3, 4, 5, 6, 7, 8. So roughly speaking, we're getting this graph, which is called the increasing graph. As you go from left to right, it's rising. So these are the three basic graphs that I talked about. I have a handout about these. And then the fourth one we'll discuss when we do radicals. So keep those in mind. X squared is a U shape, x cubed is a no shape, it's increasing, and absolute value of x is a V shape. Now, based on these basic graphs, we're going to talk about vertical shifting and translation. So, vertical shifting or vertical translation. So let y equals f of x be a basic graph. And what is a basic graph for us now? It's the ones that we know, x squared, absolute value of x, and x cubed that I just went over. Okay, so it could be any one of them. The graph of y equals f of x plus c, and notice the c is added outside the parentheses, is a vertical shifting. So that's going to be up or down, vertical shifting of the basic graph, It will be c units up if C is positive, so it's +2 or +3, you go up 2 or up 3, and the C units down if C is negative. You see, all these notes are on a handout in the notes that I have for you. The handouts are on D2L. Under handouts, you will see all this, okay, what I'm talking about. They're all in here. So for example, if I want to graph y equals x squared plus 2, you can see the +2, that's your C. So let's just do a t-chart. Y equals x squared, which we already did, versus y equals x squared plus 2, so you can see what's going on. So if you plug the -2 in, 1, 0, 1, 4. Now if you plug the -2 in there, you get the 4, and then plus you add a 2, so you get a 6. You get a 1, you add a 2, you get 3. 0, you add it. So you can see how the +2 is working out. And then a 1 plus 2 is 3, and then a 2 plus 2 is 4. A 4 plus 2 is 6. Alright, so you can see the graph is going to shift 2 units up. So -2, 6. 1, 2, 3, 4, 5, 6. -2, 3. -1, 3. 0, 2. And then 1, 3. And then 2, 6. So it's like you took the basic graph and you shifted it 2 units up. This should have been the basic graph, and it's shifted 2 units up. This is y equals x squared. Okay, and if it was -2, then it would be pulled 2 units down. So you always have to watch out for the vertex, this point. Okay, you always want to know where this point ends up. Now the second kind of shifting is what we call horizontal shifting. Horizontal, so it's going to go sideways. So the graph of now you can see the C is inside the parentheses. It's acting on the X, so it's going to move it sideways. Is a horizontal shifting of the basic graph, which is y equals f of x. It will be C units to the right if C is positive, but be careful, there's a minus there. So if C is positive, so you're going to have x -2, you would move it to the right. If it was x +2, you would move it to the left. It's opposite to what you see. C units to the left if C is negative. For example, if you want to graph y equals, you can see the -2 is inside the parentheses. So if you compare this with that, and then the 2 is C. So C is positive, so we expect this to move to the right, even though you have a minus there. Okay? And you can see what's going to happen. So the basic graph starts at 0, 0. It's going to move 2 units to the right. So this is your main point, the vertex. And then you copy and paste. You don't have to make a t-chart. I just was showing you the t-chart so you can see what's going on. And you can check actually that this point is actually on the graph by plugging the 2 for x. Look what happens. 2 minus 2 is 0. 0 squared is 0. Y is 0. Okay, so you know you moved the right way. Then if you have a reflection about the x-axis, when does that occur? Reflection about the x-axis. This happens when you have negative in front of f of x. So the graph of y equals negative f of x. You have a negative in front of f of x is a reflection of y equals f of x in the x-axis. Why is that? Again, let's look at the chart. Y equals x squared, that's your basic graph, and y equals negative x squared. So you have a negative in front of f of x, okay? So when it was negative x squared, when it was x squared, if you plug these values, again, we already did that twice. When you have a negative there, it's going to make the 4 negative, the 1 negative, 0, it's going to stay 0, and then negative, negative. So when you do the graph of negative x squared, it's going to be negative 2, negative 4, negative 1, negative 1, 0, 0, 1, negative 1, and then 2, negative 4. So it's like you took the basic graph and flipped it in the x-axis. Okay, this should have been the basic graph. So it's flipped in the x-axis. Okay, so now what if we have multiple transformation or shifting within the same problem? So what we want to do, if there's more than one that needs to be done, we got to do them in order. Which order do we follow? Here's what we need to do. So for multiple translation, okay, let me fix this a little bit. I don't like focus. Okay. All right. For multiple translation, you want to do horizontal shifting first, which is inside the parentheses. Then you want to do reflection, which is timesing by a negative, reflection in the x-axis. Then the last thing you want to do vertical shifting, which is outside. Okay, so you do horizontal, which is sideways, then you flip if there's a negative in front of it, then you do vertical. Okay, so for example, if you have, say, y equals negative absolute value of x plus 2, so you can see my basic graph is not a U-shaped anymore. Now it's a V-shaped. So there's nothing inside the absolute value, so no horizontal shifting. There's a negative, so we're going to flip it, but then move it up 2. So we're going to flip and then up 2. So instead of V-shape, it's flipped, but then it's moved up 2. So that's up 2. That should have been 0, 0. It should be now 0, 2. That's your main point. And that would be your graph. And if you have, say, y equals negative absolute value minus 2 plus 3, then you have 3 things you need to do. You're going to do what's inside the absolute value, which is right 2, and then you're going to flip in the x-axis and then up 3 in that order. 1, 2, and then 3. Okay, you do what's inside, which is horizontal, then you do the negative, which is flipping in the x-axis, then up 3 for the outside the absolute value or outside the parentheses. So you move right to the right 2, it's upside down, but then you go up 3, but it's upside down. And this point should always be labeled. This time it's 2, 3. Alright, I want to show you an example about x cubed. We haven't done any of that. So if I say graph y equals x minus 3 cubed plus 2, so this shows that I gotta go right 3. Remember, inside the absolute value, inside the parentheses, it's opposite to the sign. If you see negative, it's to the right, positive to the left. This is the same as the sign. Positive is up, negative is down. So you're going to take x cubed, which you have on the handout, which we went over, x cubed, and then you move it right 3 and then up 2. So it's going to be right here instead of 0 0, it's going to be right there. So you copy and paste. Roughly it's going to look like this. Okay, now let's look at some examples from your textbook. Page 639, number 24. It says find domain and range of each function. So domain and range from each function, 24, page 639. So I need you to be looking at your text. When we do this, this is at 2, the main point is at 2, 3. And then it's a V-shaped graph. Remember, domain is your x values and range is y values. So you can see domain, you're going to go sideways. This is your x, this is your y. So if you go all the way to the left, will you always have a y value? Of course you will, because this is going to go indefinitely. You will always have a y value. So from negative infinity to 0, you will have a y value. From 0 to infinity, you will also have a y value. So the domain is all real numbers, because for every x you can find a y value. Now the range is all the y values that are paired with an x value. You can see any y value you pick, 3 or higher, can be matched with an x value because there's a graph there. Once you go beyond 3, there is no x, there's no graph. So your range starts at 3 and goes up to infinity. So from 3 to infinity. And I put a bracket because it includes 3. At 3, we have an x value of 2. Okay? So this is just purely about domain and range. Another example, 28. From page 639, again domain and range. It starts at 0 0 and goes indefinitely this way. That's your f. So domain of f. Again, your x values, if you pick any x value here, there is no graph. From negative infinity to 0, there's nothing. Now when you start at 0, you have a y value of 0, so that's in the domain. 1 will have a negative y value. As long as you have a y value, I don't care. So from 0 to infinity, you will always have a y value. So 0 to infinity. Range. Okay, you can see if you go above 0, no x value, no graph. If you go below 0, from 0 to negative infinity, there is a graph. So negative infinity to 0, which is the range. Okay, let's look at '66. In 66, you need to be looking at the graph of the function. It's finding f of -1. So you're gonna find, so when x is -1, what's the y value? That's basically what you're looking at. And I'll give you the answer. It's -1, and then f of 0 is 0, and so on. So check that out. Make sure you understand that. If not, shoot me an email. Page 641. That's it for this section. Okay, that's all I wanted to do.